this flyby, we will have so much more information than we had before. We'll know a little bit about perhaps its spin rate, its size.
Yeah, currently there's only limited information available, and the majority of it comes from unpublished work that was done by Nick Moskovitz at MIT last year, shortly after the asteroid's discovery. He found that it has a rocky silicate composition similar to the composition of many Earth-approaching asteroids, and also many meteorites that we find. It appears to rotate about once every 6 hours, and as it rotates, its brightness fluctuates considerably, and as a result, we think that it's quite elongated. But at this point, that's all we know, and so we'll find out more, we hope tonight, if things go well with the Goldstone observations.
So you only know, or you have a guesstimate of its size. We think it's about 150 feet in diameter, but it could be bigger or smaller.
It's conceivable that it could be somewhat larger or smaller. There aren't really any actual measurements of its size yet. Instead, what was done by Nick Moskovitz was to basically to get an estimate of its composition from what's known as visible near-infrared spectroscopy, and then from that to infer, based on what we've seen for previous objects with a similar composition, how big this one is likely to be. But the uncertainties could easily be several tens of percent.
All right, well, we'll be looking forward to your data, and you'll be heading out to Goldstone at about 4 o'clock today, just a couple hours.
No, I'll be heading out in about an hour.
Oh, really?
Yeah,
okay.
The Goldstone observations started at 10 after 4, so I need to be out there
before
that.
then.
Yeah.
Okay, well, we're looking forward to your data and your information. We'll know a whole lot more.
Very much.
Okay, so we're just a few minutes away from the closest point that DA14 will be to the Earth, and we can bring you more images from Gingin, the observatory outside of Perth, Australia. And we're going to take a break just briefly when we bring back Paul Chodas, our scientist with the Near Earth Object team here at JPL. Paul Chodas is back with us now, and we are back on this live image of the shot from Gingin, and we see it's a clear shot.
It's a beautiful night down there. Now, bear in mind, we can't see the actual craters or any of that in even the largest telescopes. All we're going to see is a point of light moving against the star background.
But it is indeed a really fast-moving object.
Yes, it's a real challenge for astronomers to track this. It's moving so quickly, and in fact, it's so close that you have to figure out where you are on the Earth to figure out to look, what direction to look, what constellation it would be in.
We have a diagram of yours that can actually show folks where it's coming from, and we can cut to it. This is a diagram that Paul made himself. Here it is.
Yes, so on this diagram you see the Earth as the green circle, and there's a line going through it which is the geosynchronous satellite ring. That is the ring of satellites that encircles the Earth, and we're looking at it edge on, which is essentially the equator. The asteroid now is passing from the bottom to the top, and there are little time tags indicating at what time it is at what point, and we're getting very close to the actual closest approach. So it is just below that satellite ring, and very soon it will pass within the ring, which is essentially the time of closest approach.
And folks are worried about that, worried about, is there any possibility that one of the satellites could be affected?
We have checked for that. We've cooperated with the U.S. Space Command in checking where all the satellites will be at the time, and there's no chance that this asteroid will run into a known satellite.
You're very comfortable with the orbit of this particular asteroid. You think that you have it down? You're pretty certain where it travels?
We've been observing this asteroid for almost a full year, which is a long time for a small object like this, and we know its asteroid orbit so accurately to within 100 miles or so that we can be confident of these things. The closest satellite will be much farther away, 10 times farther away than our uncertainty.
So it is on an orbit, which would mean that it could come back.
Yes, and in fact in that diagram, as you recall, you could see the effect of the Earth on the asteroid. There was a significant bending of its trajectory. So the asteroid orbit will change quite a bit after this close approach. Before this close approach, its period around the Sun was 366 days, And after this close approach, it will be 317 days. Its orbit actually will shrink a little, its orbit about the Sun.
So when will it come back, and where will it come back to?
Well, we'll project that into the future. It seems that it could make a close approach in the year 2046, but that it cannot hit. Its orbit is known so accurately that we can project actually through most of the 21st century. And right now we're looking at the possibility, a very tiny possibility, that it could hit the Earth in the year 2080. I expect that will go away, and we'll know that we're safe from this asteroid for a long time.
And how will you use the information that Lance was talking about, the information that the radar can give us?
Lance's information is very helpful in computing the orbit. We will have essentially nailed the orbit of this to, it'll be one of the best in our catalog. It's that accurate.
All right. We are 50 seconds away, 49. The clock is counting down, and at that point, in just a few seconds, that is the closest point that DA14 will be to our planet.
To our planet in centuries, probably, as far as we know. So it's a remarkable moment as it passes by, and then it will be headed out.
And watching the counter on the left, the distance to Earth.
Yes, it's going to go through about 17,200 some miles. That's as close as it will get, and then it will start heading out.
And that's at the point where folks in Europe and then finally North America, as it's heading out, is about the time that we'll be able to see it.
Yes, it's going from the far south. Now it's over the equator, and it will be heading straight north and going essentially near the North Pole. So now we will have the polars in the sky, and we'll have a chance to see it from the northern hemisphere now.
All right. The counter is 0. It has passed closest approach, and this asteroid is going away.
It's on its way out.
It's been here, done that.
But throughout the day, it'll be observed by observatories around the world, and we'll get a lot of good information on its spectral type, chemical composition possibly, spectrum of it, and the radar data will give us essential information on the shape and size and the rotation.
What's very interesting is how much information you're getting from hobbyists, from amateurs. It's as though the more eyes are always better.
Yes, it's a worldwide effort, and astronomers around the world send in data on these asteroids, and they're all collected and all used in a combined solution to figure out its orbit.
All right, so what's next for NASA missions regarding asteroids?
Well, NASA has a planned mission to go to visit one of these near-Earth objects. That's the OSIRIS-REx mission.
We have some footage of it, in fact, that we can show folks. Now, this is a mission that actually will visit an asteroid.
It's going to go to a near-Earth asteroid, a little bit larger. This one is called 1999 RQ-36. Here you see the spacecraft approaching it. It's launched in 2016. It approaches it in the year 2019 approximately. It will reach out, take a sample. You saw a little puff of dust.
Yes.
It will put the sample into a return capsule and bring that back to the Earth, so we'll have actual samples of a near-Earth asteroid.
All right. Well, we're through. DA14 is on its way, but we will continue our observations of it, and we will be seeing it here in the United States pretty soon.
This evening.
And so that wraps things up here. We would like to thank all of the observatories that helped us out today. That's Southern Cross in Tasmania, Sanford Valley in inner Brisbane, Australia, of course the Gingin Observatory outside of Perth, Australia. And JPL will continue to push out these images of DA14 as it moves over towards Europe and then over to the Northern Hemisphere in the United States, North America. You can see these images on our Ustream channel. That is http://www.ustream.tv and then NASA JPL2. And then later on today, NASA's Marshall Space Flight Center in Huntsville, Alabama, they will also be streaming images from their telescope. And you can see those here in the United States from 6 p.m. to 9 p.m. Pacific time. That'll be 9 p.m. to midnight. And you can search for their feed at www.ustream.tv, and that will be NASA-MSFC. And finally, if you're interested in learning more about asteroids, there are 2 websites to check out. That's www.nasa.gov/asteroid-flyby altogether. And you can also follow us on Twitter, twitter.com/asteroidwatch, and you can get tweets all about asteroids. Oh, that wraps it up for us. Thank you so much for joining us. And again, many thanks for all the observatories that helped us out today. Take care.